Section 5.7, linear inequalities in two variables. So here's some reminders. Linear inequalities in two variables is something like this. 2x plus 3y is less than or equal to -6. So again, we have an inequality with two variables in it. A solution to a linear inequality in two variables is an ordered pair that produces a true statement when the values of x and y are substituted into the inequality. You'll see this in our first example. So here's example number 1. Which point is not a solution of x plus 2y is greater than or equal to 7? So what we're going to do is take each one of these points, substitute the values in for x and y, and see which one does not make this side greater than or equal to 7. So looking at part A, I'm going to put -1 in for x and 4 in for y. So I got -1 plus 2 times 4 is greater than or equal to 7. To simplify, take 2 times 4 first to follow the order of operations. Since 2 times 4 is 8, I ended up with -1 plus 8 is greater than or equal to 7. Since -1 plus 8 is 7, I get 7 is greater than or equal to 7. 7 is equal to 7, so that makes -1, 4 a solution. Remember, we're trying to find which one is not. So let's move on to part B. Let's put 2 in for x and 4 in for y. To simplify that, again, I would take 2 times 4 first and then add the 2. I would end up with 2 plus 8 is 10, and 10 is greater than or equal to 7, so 2, 4 is a solution. So let's move on to part C. Put 11 in for x and -2 in for y. I'll take 2 times -2 first. So I end up with 11 plus -4. 11 plus -4 is 7, and 7 still is greater than or equal to 7 since it is equal to 7. So -2 is a solution. Moving on to part D, putting 8 in for x and -1 in for y. I would take 2 times -1 first to end up with 8 plus -2. 8 plus -2 is 6, and this time 6 is not greater than or equal to 7, so therefore 8, -1 is our answer for the point that is not a solution to the inequality. Now let's move on to graphing. Yes, the beautiful graphing that you all love so much. So here's example number 2. Graph the inequality y is greater than or equal to 3x plus 1. So we're going to graph it just like we normally do. We always want to get y by itself, and be careful when you're getting y by itself. If you end up multiplying or dividing by a negative, you still need to flip the sign. So since the y is already by itself for this problem, I'm just going to start off by identifying what the m and the b are, so the slope and the y-intercept. The slope is still going to be the number in front of x, and we always want it as a fraction. So the slope is going to be 3 over 1, and the y-intercept is the number without a variable, so our y-intercept here is 1. Remember, I graphed the y-intercept first on the y-axis. So there's my y-intercept, and then I will do rise over run to find the other point. So I would be going up 3 and to the right 1, starting from that y-intercept of 1. So now I have 2 points, and remember, 2 points determine a line. And normally I would just connect those 2 points with a nice straight line, but there's going to be a little stipulation to this. You are going to draw a solid line if it is equal to. You will draw a dashed line if it is not equal to. Since this problem is equal to, I will draw a nice solid line. So once again, I will draw a nice solid line through those 2 points since my inequality was equal to. So there's my nice solid line. I would write down this part in your notes so you know when you need to draw a solid line and when you need to draw a dashed line. The other stipulation to this is shading. If it's a greater than symbol, I will shade above it. If it's a less than symbol, I will shade below it. Again, I would write down this part in my notes so you'll know when to shade above and below. So once again, we had a greater than symbol. So whenever the variable is on the left-hand side, when y is on the left-hand side, if you have a greater than symbol, you're going to shade above it. If it's a less than symbol, you're going to shade below it. So since we had a greater than symbol, I'm going to shade above. And what this shading means is that since I have an inequality, any point in the shaded area, and including on this line since it was equal to, any point on that line or above that line, if I were to substitute those coordinates in for x and y into my inequality, I will get a true statement. Any points over here would not give me a true statement. Let's look at another example. We have example number 3. Graph the inequality x plus 4y is less than -8. So notice in this problem the y is not by itself, so that's what I'm going to do first. So the first thing I will do is subtract x from both sides. So I end up with 4y is less than, I'm going to go ahead and put that negative x in front of the negative 8. And remember, there's a 1 in front of that. Then I will divide by 4. Y is less than, I did not divide by a negative or multiply by a negative, so I'm going to keep it as a less than symbol. And negative 1 divided by 4 is negative 1/4. So I'd have negative 1/4 x, and negative 8 divided by 4 is negative 2. So now I have a slope of negative 1/4 and a y-intercept of negative 2. Just like always, I will graph the y-intercept first and then use rise over run to plot the other point. So I'm going to go down to negative 2 first and then down 1/4 to get my points of my graph. But again, before I draw my line, I need to look at my inequality symbol. So I'm going to look at my inequality symbol that I got once I got y by itself. And again, y has to be on the left-hand side. I'd make sure I'd write that down. Make sure y is on the left-hand side of the inequality. Since ours is, then I will look at that inequality. I have a less than symbol. It is not equal to, so that means it's going to be a dashed line. So to draw the dashed line, I'll just simply dash my line instead of drawing a solid line. Since it was less than, then I need to shade below it. So I'll just take my pencil and shade below it. So again, this means that any point in this shaded area will give me a true statement when I substitute those x's and y's into the original inequality. Any points along this line would not work since it is not equal to. So again, I shaded below the line because it was less than once I got y by itself, and I dashed the line because it was not equal to in my original problem. And now we'll do example number 4 and example number 5 side by side. Example number 4 says, graph the inequality y is less than 1. So notice that we don't have an x in here. So my mind is automatically thrown to Hoy and Vux. Since this is a y, I know it's going to be a Hoy problem. A Hoy line is horizontal, has a 0 slope, and it's y equals. But in this case, it's not y equals since we have an inequality, but we're still going to have a horizontal line. So I'm going to go up to where y equals 1 and draw a horizontal line through it. However, since it's not equal to, I'm going to do a dashed line. So there's my dashed line, and again, I did dash because it is not equal to, and it says y is less than 1. Y is less than 1 below that line, so I'm shading below it. Now moving on to example number 5, I have graph the inequality x is greater than or equal to 2. So again, Hoy and Vux. This would be a Vux equation since it is x equals, or x is greater than or equal to, but still it's x. So this time it's going to be a vertical line with an undefined slope because it was x equals or x is greater than or equal to. So I'm going to go to where x equals 2 and draw my vertical line. However, I need to make sure whether I'm going to draw a dashed line or a solid line. Since it is equal to, I will do a solid line through x equals 2. So there's my line, and then it says x is greater than 2. Now it's a little bit harder to figure out where to shade this time because there really is no above or below the line. But just think about x is greater than 2 to the right of 2, not to the left of 2. So that just means that any point in this shaded area would satisfy this inequality, just like any point in this shaded area would satisfy that inequality. And that's actually it for this section. Make sure you jot down anything you don't understand that we can cover in class before we move on, and we'll see you then.